everyone, Tina here, and today I'd like to talk about vectors. Specifically in this video, I'd like to talk about the harder vectors questions you can come across if you're doing the higher GCSE course. I'd recommend you watch my Vectors Essentials video before watching this one if you haven't already. I think the best way to tackle this topic is just by looking at a few different examples because the style of question you can be asked can be quite varied. Here's our first example. So we've got a diagram and then a bunch of information underneath. So I'd always recommend starting by looking at the diagram against the information and trying to match it up to make sure you're happy with what's going on. We can see we've got vector OA labelled as A, vector OB labelled as B, and then it says P is the point on AB such that AP to PB is 1 to 3. Now P is not actually on the diagram, so we should put it on there, and I think it should go somewhere there. The reason for that is the ratio is 1 to 3, so we've got one part there and 3 parts there. Always a good idea to label on the ratio parts. Next, the question says OP is K times 3A plus B, and our job is to find the value of K. It can be difficult to know where to start with these kind of questions, so I'd recommend just starting with looking at the information you have, thinking about what you want to try and find, and in this case they're talking about vector OP, so let's find vector OP on a diagram. There's different ways of getting from O to P, but one way you could get there is going up here and then down here. So on the side we can write OP equals OA plus AP. Once you've got your vectors written down, you can see what you know and what you don't know. So vector OA, we know that that's lowercase a, so we can write that there. And then vector AP, we don't actually have an expression for that yet, so we should probably try and get one. Now, I know that from the ratio, A to P is actually a quarter of the way along A to B. Reason is the ratio is 1 to 3, and that ratio is the same as 1/4 and 3/4. If you were going to split that line AB up into that ratio, you'd go 1/4 to P and then 3/4 down to B. Once you've established that, that's quite nice because now you can find a path from A to B, so vector AB. We could go round this way, so we could go from A down to O and then from O to B. So I'm just going to replace that vector AB with minus A plus B. Once you've got that, it's just a case of expanding and simplifying, just like in algebra. A minus 1/4 A plus 1/4 B. And then simplifying, we get 3/4 A plus 1/4 B. So now we have an expression for OP, and the question also had an expression for OP. So if we compare, it's looking quite similar now. All we have to do is try and make it look like K brackets 3A plus B. So if we maybe take out 1/4, factorize out 1/4, we will actually get 1/4 brackets 3A plus B. And that is in the format that the question is asking for. So ultimately, the value of K is actually 1/4. Let's have a look at the next example. So for this example, we've got a regular hexagon and we're also told some vectors. So we've got OA is vector A, OB is vector B, M is the midpoint of BC, so directly in the middle, and X is the point on AB extended such that AB to BX is 3 to 2. Again, X isn't actually on our diagram at the minute, so we can pop it on. Based on this, we would put X somewhere there because it says X is the point on AB extended. So we would extend AB and stick X there. Again, make a note of the ratio, so 3 to 2. This question wants us to prove that EM and X are on the same straight line. So if we just try and visualize that, is that looking like it's going to be true? Probably, because we can draw a pretty convincing straight line between EM and X. But how do we prove it? There's a trick here, and I'll show you how it works. With questions like this, when you want to prove that 3 points are on the same straight line, you want to get 2 vectors that are part of that straight line and show that the 2 vectors are parallel to each other. You want to show that they're parallel, and you also want to show that they share a point, because if 2 vectors are parallel, but they also share a point, that is going to mean that they're on the same straight line. I'll show you how that works. We could start by looking at vector EX. So how do we get from E to X? Let's have a look. EX. We can't go directly along this orange path because there's not enough information. So there's got to be a way of going round. we can go round by going up here, and then across there. In terms of the vectors, because this is a regular hexagon, this vector here is actually also going to be A, and this vector here is also going to be B. This vector here going across from A to B, you can again just find an alternative path. So you can go down here to O and then up there to B. So that vector there is actually going to be minus A plus B. And then to go from B to X, we can use that ratio to help us. Let's put that together. So e to x is going to be A plus B plus our vector AB, which we worked out was minus A plus B. And then to go from B to X, we actually want to do 2/3 of A to B, because that ratio told us that AB to BX was 3:2. So BX is 2/3 of AB. Let's replace that AB with the minus A plus B. And then all we have to do is expand and simplify. Okay, so we have an expression for e to x. Next, we're going to find an expression for e to m. And again, there's no direct pathway, so we're going to find a path around using vectors that are labelled. So this time, I think we're going to go up here, across there, and then down there. So writing that out in a row, that looks like this. We've got A plus B plus our vector AB, which we learned was minus A plus B. And then to go down from B to M, that's actually minus a half A, because remember M was the midpoint between B and C, and therefore it's going to be half of A going in the other direction, so minus a half A. If we tidy this up, we get this, and that's vector EM. So we've got vector EM and we've got vector EX, and now we want to show that these two vectors are parallel. To do this, we need to show that these two vectors are multiples of each other. So just from looking at this, it might not be obvious whether the two vectors are multiples of each other or not. So you can do some investigation by maybe dividing the different parts by each other. So for example, if you did 8/3 divided by 2, you get 4/3. So that shows that this divided by this is 4/3. If we do the same for the A component, so minus 2/3 divided by minus a half, we actually also get 4/3. So this means that vector EX is in fact 4/3 of vector EM. So EX and EM are parallel. So we've shown that the two vectors are parallel, but that's not quite enough to show that they're on the same straight line. So we also need to state that vectors EX and EM share point E, as in they both have the point E in them. So that is enough to prove that EM and X are all on the same straight line. Okay, last example. So this time we've got OAB, which is a triangle, and we're told that vector OA is 5A and vector OB is 2B. We're then told that T is the point on AB such that A to T to B is 5:1. So I'm just going to pop that ratio on straight away. We want to show that OT is parallel to the vector A plus 2B. So OT is the line that goes from O to T, so worth putting that on. And if we want to show that it's parallel, let's consider it as a vector. So vector OT, let's think about a path that will get us from O to T. Different ways of doing this, but the way that I'm thinking of here is to go across there and then up there. So I'll just make a note of that. To go from O to T, we're going to go OB plus BT. Now let's fill in what we know. So vector OB is 2B, and then BT is actually 1/6 of BA. We saw something like this earlier in the video. So the reason it's 1/6 is because the ratio is splitting it up into 1 and 5. So in terms of fractions, that's 1/6 and 5/6 of the line BA. We don't have an expression for BA at the moment, but we can find one by finding a pathway between B and A. So we could go from B to O and then from O up to A, and that would be 1/6 of minus 2B plus 5A. We still have our 2B in the front, so let's put that there. And now we have something that we can expand and simplify again. So let's go ahead and do that. Now we're at this point where we can't really simplify anymore, so let's look at the question again. Can we show that this is parallel to the vector a plus 2b? To do that, if we can factor out a number and then show that the vector a plus 2b is left in brackets, that will do the job. So I think we should pull out 5/6, and if we do that, we'll be left with a plus 2b inside the brackets. And this is enough to show that it's parallel. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already, and do share this with anyone else that you think might find it helpful. Thanks, and see you next time.